Hello everyone, I would like to introduce you to our first class. This class will be our first in our Python tutorial series, which will be taken by Ali Akolade and I, Oloyede John. Before I start this class, I would like to tell you a little bit about me. I'm an alumni of Udacity, graduated with a front-end nano degree. I'm a certified front-end developer. I've been coding Python now for more than 2 years. I'm also a graphics designer, and as most of you should already know, I'm a student of Bowen University. I would like to jump into the class. We'll start with what is Python, or basically, first of all, what is programming? Programming, when people think or hear programming, they basically think of people that sit on their laptops all day writing gibberish, or people that hack different things such as websites, banks. But I'd like to tell you that's not what programming is. Programming is simply a way to instruct the computer to perform various tasks. That is simply what programming is. Telling your computer to perform various tasks. Programming is the art and science of translating a set of ideas into a program, a list of instructions that a computer can follow. And the person writing a program is known as a programmer. I would like to explain to you an example or give you an example of what an instruction is. This is a simple example of telling a computer or asking a computer why a lamp does not work. The computer first checks using various instructions given by you, telling the computer to check, is the lamp plugged in? If no, plug in the lamp. If yes, then something else must be wrong. You give in another instruction. Check if bulb is burnt out. If yes, replace bulb. If no, repair lamp. It is very simple. But there's only one difference. The way a computer interacts with users is different from the way humans interact with fellow humans. Yes, we might talk in English, French, Japanese, but it's quite different with when a human or a user interacts with a computer. You need something called a programming language. Basically, a programming language is that language that helps you interact with a computer, because a computer does not accept English. A computer speaks in binary codes, and it will be weird and very hard typing 010001. So we need something that translates normal English into what the system or what the computer can understand. Now, why do we need to program? There are various problems out there, various problems that can't be solved using the normal human resources. We need to find a way whereby, or something faster that can help us solve those problems. That is where programming or programs come into perspective. Basically, you have a problem that needs to be solved. You have human instructions. You give the human instructions to the system using a programming language. The system converts the programming language into binary, then solves the problem. It's as easy and simple as that. There are so many programming languages out there. So many. We have Python, we have C#, we have Java, we have Ruby, we have Pascal, we have SQL, we have JavaScript. There are so many programming languages out there. But today, the only one we are going to focus on is the Python programming language. Python was developed by Guido van Rossum in 1989. It's a very simple programming language to use. So easy to learn. You can learn it without facing any problem. Unlike most programming languages where their syntax are very hard to learn due to various implementations you need to add, Python is very simple and is mathematically inclined. As we move on, you will get to understand what I am talking about. Before we get started, we need to figure out where are we going to write our programs. You can't just open Microsoft Word and decide to start saying you are going to write programming Python code on Microsoft Word. It cannot run. You need a system that can, or a software that can run such programming languages. That is where IDE comes into perspective. IDE is basically integrated development environment. It's a software that allows you to code and compile Python programming languages. I would like to show you different IDEs that Python has. You have Spider, ideally, PyCharm, Vim, Atom, Jupyter. But for now, I will show you how to download ideally, Spider, Anaconda, and PyCharm. So basically, you search for, to download ideally, you search for Python. You get there, welcome to Python.org. You click on downloads, then you choose which OS you are using. I am using Windows. Basically, you can see the latest releases of all Python all Python IDLEs. We have Python 3.83, 2.718, and you can see previous releases from previous dates. I will advise you to download the latest IDLE. There's another IDE that is very easy and less complicated to use. That is PyCharm. Basically, this is also very easy to download. When the page loads up, I don't know why my Wi-Fi is a little bit slow today. As you can see, the download button is already there. You click on it and you have two choices to choose between professional and community. I would advise you choose community because it's free and open source, and most of the things you need in basic and advanced Python programming can be done on this community version. So you don't basically need professional unless you're working in a company or you're working in a team that is ready to pay. Now there's one that I use, which is Anaconda, and it's very nice because it comes as a package with various Python IDEs integrated with it. That is Anaconda. Basically, this is very simple and easy to download. You go to pricing options, click on pricing. You have individual, team, and enterprise. I'll advise you choose individual because even though it doesn't come with mirrored cloud-based repository or custom repositories, you can basically do whatever you need to do on Python on this. You click on learn more. As you can see, you can click download here and you see the various IDE that comes with this Anaconda package. So before we get started, we will talk about data operators, data types and operators, and also variables. That is what we are going to talk about in this Python class. What is a variable? A Python variable is a reserved memory location to store values. In other words, a variable in a Python program gives data to compute or processing. Every value in Python has a data type. Before I start showing you examples, I forgot to tell you that today, for today's tutorial, I'll be using Jupyter. I'll be using Jupyter to code my Python code. Basically, I'll be using Jupyter. So let's write some simple codes before we go into variables. It's very easy and simple to use. Just click on new, write on through, and a new page comes up. We're going to call it, save as, Python tutorial 1. As I said before, Python is mathematically inclined, meaning you don't need a various syntax to identify what a number is. Python already knows it. Python is basically like a calculator. So you can simply do 2 plus 2 and run it, and to give you an answer, you can do 5 minus 2. to give you an answer. And unlike normal typing in class whereby you write 2 times 2, this doesn't work because basically Python looks at this x as a string. Like now if I run it, you see it gives me a syntax error because it does not understand why this is in between two integers. So for you to do multiplication in Python, you have to use the asterisk sign, which is 2 times 2. Now if I run it, you see that it gives me the actual answer. We can also do division, 5 divided by 2. If I run it, you can see my answer there. Now, as I keep saying, Python is mathematically inclined, so it comes with board mass. So basically, if I'm going to do 5 plus 4 minus 3 times 4, when I run it, as you can see, my answer comes out as minus 3. That's because you first do 4 times 3, which is 12, and 5 plus 4, which is 11, which is 9, sorry. 9 minus 12 is equals to minus 3. So now, as we talked about variables, as I said, variables are reserved memories or memory locations to store values. So instead of me always writing 2 plus 2 or saying 5 plus this, I can assign a value to a variable basically by doing a is equals to 5. Now if I decide to print out a, as you can see, my answer is 5. That is because 5 has been stored in a. I can also decide to do b is equals to 7. Now if I decide to print a plus b, my answer will be 12. That is because 7 was stored in b and 7 plus 5 is 12. Now before we go in depth into other variables, I would like to tell you that there are various rules when writing variables. These are a variable name must start with a letter or the underscore character. Basically, you cannot start a variable with an integer. Let's do something like this. 5j is equals to 6. When I run this, as you can see, it gives me a syntax error because this cannot be recognized as a variable. You can start a variable by doing underscore 6 underscore John is equals to, or underscore name is equals to John. If I print it out, sorry, cancel. If I print it out, underscore name, I can basically, sorry, I forgot the syntax error. As we move on, I'll explain why I put those strokes up there. Now, if I run this, as you can see, it's running properly. I can also decide to do name underscore age or equals to 26 or 56. Print. As you can see, it's running 56. Now, there are other rules. A variable cannot start with a number. A variable name can only contain alphanumeric characters and underscores such as A to Z, 0 to 9, and underscore. You can't have symbols when creating a variable. It's not possible because Python has assigned those symbols to various functions. So if you do something like asterisk, which has been assigned to be multiplication, and you put asterisk A equals to 67, it gives an error, a syntax error, because as you can see, start assignment target must be in a list or tuple. Now, what other rules are there? Variable names are case sensitive. This is a very serious one. Age, as you can see, we have small letter H, capital letter A with a GE, small letter G, and A, capital letter AGE. All these are three different variables. All these are three different variables. You can't say this age is a variable, then go and write this to print it out. It will bring out a very big error. Okay? If I type age is equals to 87 and I decide to do print age, capital letter H, as you can see, it's going to give me a very big error saying that capital letter AGE is not defined. See, name and just age is not defined. So when writing variables, always remember that wherever you write your variable in, whatever case you write your variable in, always remember that that is the same case you use when calling that variable back. Now we are going to move on to data types. Python data types. Basically, Python has two types of data types, which are immutable data types and mutable data types. Immutable data types are data types that cannot be changed after being created. They cannot be changed. But mutable data types can be changed after being created. As we move on, you will understand what I mean. The first data type we're going to start with is the Python number. Basically, integers, floats, and complex numbers. Integers, floating point numbers, and complex numbers fall under Python number categories. They are defined as int, float, and complex. If you want to check the types of whatever integer you're using, you can use the type function or the isInstance function. Let me give you an example of checking various types of Python numbers. We can basically go here and write a is equals to 56, b is equals to float. Sorry, b is equals to 34.0. Then c is equals to one plus 3j. Now to check using the type function, you write print second. You type print a. Sorry, give me a second. I don't know my cursor is behaving. Print a. Look at a is the type. Then let's check if b is actually a float. Then now we're also checking if c is a complex number. We are going to use the isInstance function for this for checking if c is a complex number. Basically, we're writing is if 1 plus 3j is a complex number, write true or false. That is basically what we're doing. So you see is complex number question mark isInstance 1 plus 2j complex. Now when I run these three functions, sorry, give me a second. A is a type of, okay, is a type. Okay, now I see where my error is. Sorry, give me a second. I made a typographical error while typing that. There's meant to be a comma here. I missed that comma. Okay. Now when I run this, as you can see, it gives me 56 is a type class int, 34 is a type class float, and 1 plus 3j is a complex number. Now we are going to go to Python strings. Python strings are a sequence of Unicode characters, basically alphabets or alphanumeric characters. Now, as you noticed before, while I was typing, anytime I was typing alphabets, I was putting various quotes on top of them. One here, one here. As you can see here, I was putting various quotes. That's because Python does not perceive, as I said, it is mathematically inclined, so it can perceive numbers instantly, but it does not perceive characters. It does not know what a character is unless it putting it into a single quote or a double quote. Example, writing, let's type John. John's favorite hobby is food. Print. Or let me not use the print to complicate things. I can basically just do single quotes. John's favorite hobby is food. Now when I type this, when I run this, as you can see, it's printing it out. I can also decide to use double quotes and write John likes. When I run this, as you can see, it prints it out. Now, if I want to type on multiple lines, I have to use 3 single quotes, which is 1, 2, 3. And I type Johnny Walker, then goes to school. If I press enter, or when I run this, it will show a \n, which is to indicate that there is a next line over there. This is to tell the computer that yes, this is the next line. So we'll be going to our next data type. But first of all, I forgot to show you something. Variables, as I said before, variables are memory places, but they are mutable, meaning they can change. Meaning if I input something as name equals to John, and I decide to print it out, as you can see, it's printing John. But I can also decide to change that name, this name variable. I can decide to change what is stored inside to Jane. I can decide to change what is stored inside to Jane. And now if I print name again, you will see that the value stored inside name has changed from John to Jane. That is one thing you should always know, that repeating variable names will always change whatever was stored inside before to the new value. Now we are going to go to our next data type, which is Python list, which is basically an ordered sequence of items. As you noticed before, we could only store one value inside a variable. We could only store one value. But now we can decide to store a list of values inside one variable using the list data type, which is enclosed, which is listing those values with separated by commas, enclosed within a bracket. Let me give you a simple example. We literally have, let's call this variable type list, or Not to make things complicated, we can call it names. Names equals to, now remember you need brackets. So create your brackets, then you input the names. John, sorry. Always remember for strings, put your double quotes or single quotes. We have John, Janet, or Peter. Now if I call this variable name or run this variable name, print it out, you will see that it will bring out the list of all names written out inside that list. First of all, let me change this since I did capital letter. Now let me run it. As you can see, it brings out John, Janet, Paul, and Peter. But now one thing you should notice is that when counting the numbers of values inside a list, the index number is different. Unlike counting, yes, as you can see, we have four values inside this list, but it's way different for a computer when reading it. It reads it from 0, meaning we have 0, 1, 2, 3. So if I decide, okay, I want to call just one name out of this list, that is Janet, or excuse me, Janet, I basically say print names bracket, as you can count, 0, 1, and I print it out. As you can see, it prints out Janet because the index number is 1, not 2. Please don't make that mistake when coding, because many people make this mistake thinking that, okay, yes, they are going to call out number 2, but instead you are going to be calling out Paul instead of Janet. Let me and one thing I forgot to show you is that it's not only strings you can put inside a list. You can mix it up with numbers and strings. Let's call this variable mixed up, or mixed underscore equals to, you can say a John 89 56 Now if I decide to print this out, as you can see, it prints out everything. So you can input various strings and integers into a list. And now, as I said before, as I showed you before in the PowerPoint, it shows that here that lists are under mutable data types, meaning I can decide to change whatever is written inside my list. Let me show you a simple example. As you can see in this mixed up list over here, we have A, Jane, 89, 46, and Joy. But now I can decide to change what is inside this. I can decide to change what is inside this list from Jane to I can decide to change, remember index number, this will be 1, which is Jane. I can decide to change Jane into John, which will be mixed up. Mixed up 1 is equals to, now when I print out mixed up 1 again, instead of giving me Jane, it would have changed to John. As you can see, John is being printed out. And now if I decide to list out, for here, looking at it, you might think, okay, it's just that one, that it, just because I wrote mixed up 1, it didn't actually change the array. If I decide to print out this whole array again, this is what will show up. As you can see, instead of Jane, we are seeing John. Now the next thing we'll be going to is tuples, Python tuples. Basically for now, at this intro to Python stage, we will not be using tuples, sets and dictionaries, but I'll try and explain basically what a tuple is. A tuple is an ordered sequence of items, same as a list. The only difference between a tuple and a list is that tuples, when you create it, it is not you cannot change it. Once those values are assigned into a tuple, it is not changeable. And the only way you can create a tuple, instead of using a bracket, we use parentheses. This is a simple example. We can name this tuple A. That's called A. Equals to, using parentheses, you can do John, B, and 45. Now when I print out tuple A, as you can see, it prints out. But let's see if I can change it. Let's see if I can change what is inside this tuple and bring out a different result. So what I'll do is print, tuple underscore A bracket 1. Let's first check 1 is B. So let's print it out. Let's first print it out. Simply print. As you can see, it prints out B. But now let's try and change out this B to A. If we do this, tuple underscore A, 1 is equals to B is equals to C. Now if I run this, you will see it gives back an error. Object does not support item assignment, because it is not possible to change an immutable data type. Now let's move on to sets. Sets are basically an unordered collection of unique items. The only way you can define sets, unlike tuples and lists, while list uses brackets, tuples uses parentheses, this uses braces instead. For sets, you use braces. Basically, let me give a simple example. Let's do school is equals to, remember for sets we use curly braces, so we can do Bowen, now let's print out school. It prints it out. But basically, as I said before, sets are unordered, meaning while using them, we can perform set operations like union, intersection on two sets, and also sets have unique values and they eliminate duplication, meaning that when you write, like, okay, in all this, in tuples, list, you can duplicate data sets. As in, I can decide to write, values inside the list. I can decide to write Janet 3 times. But if I write that inside a set, it will print out, if I write 2 Janet, it will print out only 1. The last data type we'll be talking about is the Python dictionary. We are going to use this a lot when we enter advanced Python, but for now, you can basically just keep this in mind as Python dictionary is an unordered collection of key value pairs. It is generally used when we have huge amounts of data. So when we're entering machine learning, deep learning, we are going to be using dictionaries. Dictionaries are optimized for retrieving various data. I will not go into that for now. I will not go into that for now. Something else I would like to show you is converting between data types. Basically, I can decide to convert from float to int. Conversion from float to int will truncate the value and make it closer to 0. Meaning, if I'm truncating from float, as I said before, floats are decimals, meaning int, let's say int, we have 10.6. This is basically a float. If you want to check it out, we can do type a is equals to 10.6. I can now decide to, as we used before, remember the function type. So we do print type a. If I run this, as you can see, class of float. Now I want to change this value a, or this value 10.6, which is stored in the variable a, into an integer, which is whole number. Basically, all I need to do is write int a. Int a. Run. As you can see, it truncates it to a value closer to 0, meaning it eliminates the decimal point and truncates it immediately to 10. So when converting, there are times when you are coding and you need to convert, you might have like pi and you need to convert it into a whole number. Basically, this is what you do to truncate from a floating point to an integer. You can also convert from float to strings or from strings to float, but always make sure that they contain compatible values. Example, we can do float, meaning I'm trying to convert float 2.5, but basically, as I said before, once you put quotes up there, you are basically converting it into string. So this right now is a string 2.5, but if I click enter or I run it, as you can see, it brings it out as an integer or a float 2.5. That is basically a float. I can also decide to change for a number to a string. So basically, I just write str, which is the short form of string, str 25, and if I run it, as you can see, it changes it into a string. You can know that from the quote above it. As I said, it needs to contain compatible values. So if I do something like int 1p, p is an alphabet. There's no possible way for p to change to an integer, to a number. So if I run this, as you can see, it gives me a value error, invalid literal for int with base 10. So you can't convert alphanumerics to integers. You need compatible values to convert from a string to an integer or float. You can also decide to convert sets to tuples and tuples to lists. Let's see. I'm converting to sets. Let's give a variable a, which is a set, which is a list. Let's input our various items. You can have 89, 7, 4. Now I can decide to convert this into a set by saying set a. Now if I run this, as you can see, from the curly braces, it has changed into a set. I can also decide to change it into a tuple by saying tuple 5 tuple a. If I run this, as you can see, it has changed from a curly brace to parenthesis. I will now go into operators, Python operators. Python operators are those special symbols in Python that carry out arithmetic or logical computation. the value that the operator operates on is called the operand. Basically, we have arithmetic operators, relational operators, assignment operators, logical operators, bitwise operators, membership operators, and identity operators. For now, we will only be using the arithmetic, relational, assignment, and logical operators. What do you mean, or what do we mean by an operator? Those symbols like addition, multiplication, division, greater than, those are basic operators. Arithmetic operators, you can see here we have plus, addition, subtraction, multiplication, division, modulus, divide. This double backslash divides and rounds up to the nearest integer. Let me give you an example of arithmetic operators. We can have 2 plus 2, which will give you 4, 5 minus 3, 8, which will give you minus 3. We can have 6 times 6, which will give you 36. We can have 8 divided by 2, which will give you 4. But as you can see, it gives you decimal point. I can also decide to divide 5 by 2. It gives you a remainder. But if I want to use the backslash, if I do 5 double backslash 2, and I run it, as you can see, it gives me 2. It rounds up to the nearest value. Instead of giving you 2.5, it gives you 2. We can also decide to do double asterisk, which is exponential, which basically helps us in doing raised to power. So now if I want to do 4 raised to power 3, note, if I do this, if I use the normal raised to power symbol, which is this, raised to power 2, it will give me something else, because this is used for a different assignment. As we move on, you understand why I said we shouldn't use this. You can see it didn't give us the right answer, because 4 raised to power 2 is 8, not 6. So what we do is 4 raised to power, using the double multiplication sign, 2, and 16, sorry, 4 times 4 is 16. It gives us 16. We can now go to, from the arithmetic operators, we can check out the comparison or relational operators, which are used to compare values. It returns either true or false. We have the greater than sign, the less than sign, the equal to sign, the not equal to, the greater than or equals to, or the less than or equals to. Let me give simple examples. Let's create our variables. X is equals to 5, y is equals to 2. Now I can decide to check if x is less than y. As you can see, it gives me false, because 5 is greater than 2. I can decide to do y x greater than y. Gives you true. I can also decide to check if x is equals to y. Gives us false, because 5 and 2 are not the same. We can also decide to check x is greater than or equals to y. True. We can check x is less than or equals to y to give us false. We can also, there's also one more which I skipped, which is x is not. This will be used when we are checking conditional statements, if statements, not equals to y. It will return the value or the Boolean value true. Another operator we are going to check out is the assignment operator, which is basically equals to, plus or equals to, minus equals to, multiplication equals to, division equals to, modulo equals to, double backslash equals to, which is dividing without a remainder, and raised to power equals to. Now the reason why we use this is if we decide to do we have a variable x is equals to 5, and we want to add x by its let me create another one. Y is equals to 3, and I decide, okay, I want to do x is equals to x plus 2, meaning I want to change what is inside this x to what is x plus y, x plus y, meaning 5 plus 3. I want to change the value inside this variable from 5 to what 5 plus 3 is there. So if I can simply write x is equals to x plus y, and if I run it and I print out x, as you can see, it's going to give me 8. But I can simply do a simple style by doing x plus equals to y, and when I run it, print x, okay, it's going to give us 8 plus 3, 11, which is 11, because remember we've already changed the value inside this variable x to 5 plus 3, which was 8. So 8 plus 3 now is 11. We can also do something like x minus equals to y, print x, it gives us 8, because now we are minusing 3 from 11. We can do multiplication, x multiplied equals to 4 equals to 3. When we run this and we print out x, it gives us 24. That is basically 8 times 3. We can also decide to use the I would like to use the double backslash, which is division without remainder. That will be x double backslash equals to y. When I run this, print x, it gives us 8. Now let's check another operator, which is the logical operator, which is and, or not. We are basically checking if operands are true, if they are not true, if either of them are true, or if true if operand is false. We are not going to use this for now. As we move on, it's when we get to advanced Python, that is when we are going to start using logical operators. And so that brings us to the end of today's class. In the next class, we'll be talking more on loops, lists, and conditional statements. Wish you guys a good day. Thank you.